So this is the past HSC 2015 and question 15. They're moving a wire or a conductor in a field, and now whenever you move a conductor through a field, so there's our field and our conductor. Now it has no power, so it has no current flowing while it's sitting still. When you first move that conductor, you're moving all of the charges in that wire. The protons that are stuck in the atoms, in the nuclei of the atoms of the wire. So that's our wire. You're also moving all the electrons in the wire, and they're all heading in that direction when it first gets moved. So I'm moving the wire to the left. It's starting, all of those charges inside that wire, the minuses and the pluses, are all going to the left to start with. Now as they move to the left, they feel a force within that field. So the electrons, if they move this way first inside the wire, so they're not feeling any force while it's still, then they get moved to the left. By the right hand palm rule, the thumb is in the direction of the electron, or the moving charge. The fingers are the field going down into the page, and the charge is minus, so it'll feel a force in that direction at 90 degrees to its motion. So electron will turn that way and move up. So the electrons in the wire, as the wire moves this way to the left, the electrons will move that way. The positives move in the direction of the palm of the right hand rule. Remember, the field's down into the page, so fingers are down, thumb to the left, palm or positive charges will move downward. So they're stuck in the wire. So the positive or conventional current will move down. That's the one we use for physics. The actual electrons will move up. So if we look at this question now with that knowledge, and you look at this side of the ring, think of it as a conductor, it's being moved that direction. So if we look on the thing, so the positive charges in that wire, that's our conventional current, they're being moved in the same direction as this side of the loop. By the right hand palm rule, we put the thumb in the direction the wire is moving, our fingers in the field down into the page. So the positive charges, palm, will be moved this way. So they'll move down this side of the wire. If we look at the other side of the wire, it's being moved in this direction. So thumb in that direction, fingers down into the page. Our palm will be facing upwards now. So this side of the loop, the positive or the conventional current will move up the page, which gives us a clockwise direction. So it has to be answer A or C. Now, we're not changing the flux density, that's the number of these lines of magnetic field per unit area. So we've got the same area that's being covered. This one's longer, this one's just been, it's had it moved in, so we're not altering the actual area that's covering the field, the loop through the field. If you look at that, you can see that 4 crosses fit here, and there's 4 crosses in this side. So we're not changing the flux density, we're not making the field stronger in that unit of area, so it has to be A, the change in magnetic flux by moving across this field or changing the